So for this last part, we're asked to find solutions to this equation. 9 plus 9x minus x squared minus x cubed equals k. We're asked to find values of k where there will only be one solution. So here's our function, the one that we've been working with throughout this question. And I just ask you to imagine what happens if it intersects with a linear function. So if I have this linear function there, I can see that there are going to be 1, 2, 3 different solutions until I get above that maximum there. Up over here, I only have one solution. And so what we're looking for is the value at the top of that maximum there, where after which I'm only going to have one solution. Now, because we know that the x value at that turning point is 1.43, we know that the corresponding y value must be generated by this function and must be this limit. So if I'm intersecting with a function, a linear function, a horizontal line, y equals b, as soon as b gets bigger than this point, then I know I'll only have one solution. So that's why b is this limit here. When k is bigger than b, there'll only be one solution. So to do that, I simply have to substitute the 1.43 into my equation there and get the x value out. So when b is 16.9, that's the limit. Right? Bigger than that, I'll only have one solution. And the same thing happens for the bottom as well. Here, up there I have 3 solutions. If I go down there I only have one solution. I'm looking for that limit there, which happens at the other turning point. And these are the coordinates of that other turning point when x is minus 2.10. We got that from the previous question. So I want my number to be lower than that, bearing in mind I'm now going down the y-axis there, to make sure I've only got one solution. So at that point, when my value of k is less than this limit value, there'll only be one solution. So once again, I substitute that value, minus 2.10, in for x into the equation to get this other limit. So the question is really asking you to find the corresponding y values of this local minimum and this local maximum. You've already done the hard work finding the x values. Here you just have to find the corresponding y values.